Hey folks, this is Mr. Heier. Today we're going to talk about the types of charging, and then first of all how things get charged, and then talk about the different types. How do we get those charges to be transferred? Right. So first thing we're going to do is look at the idea of when something charges, the idea of conservation of charge. If you remember, conservation of energy, conservation of momentum says that the total amount of energy or momentum has to remain constant. Well, same thing with charge. When something is being charged, when you're touching two objects that are charged, the total amount of charge has to remain the same. Right? And so we can kind of see it this way, is that charges are created not alone, but in pairs. So here we have, if we have an NaCl molecule, sodium and chlorine, when you separate them, the sodium is losing an electron, so it's +1, and the chlorine ion has the extra electron, so it's -1 charge, and so the total charge is still 0 because a salt molecule has no total charge, right? So Q total would be equal to 0. Here, Q would be equal to +1. Here, Q would be equal to -1, and you add them together, and you get Q is equal to 0. All right, so let's look at an example. How would we do this in an example? All right, so we have a silver sphere. Right here we have a silver sphere and a bronze sphere, or a brass sphere. If it initially has a charge of +6, first of all, +6 coulombs, how many electrons is it missing? All right, you're going to have to calculate electron sum, so let's look at this again. We know that the total charge is just the number of electrons times the charge of an electron, right? And the total charge is 6 coulombs. Number of electrons is what we're looking for. And we know from yesterday's notes that the charge of an electron is 1.6 times 10 to the -19 coulombs. So we just multiply it all together, and we end up with 3.75 times 10 to the 19th electrons. All right, so now the charged silver sphere, touches a neutral brass sphere. All right, so if it's neutral, it means it has no charge at all. Okay, what is the final charge of each after touching? Okay, so the total charge, Q total, is going to be charge of the silver plus charge of the brass, which is going to be +6 plus 0, which is equal to 6. So the total charge is going to be 6. So when they touch, the silver one is missing a bunch of electrons, and it wants them. So when it touches the brass, the electrons in the brass sphere are going to move. Some of them are going to move over into the silver sphere and spread out, and they're going to keep spreading out until everything kind of balances, right? And since the total amount of charge has to stay the same, the charge will still be 6. Okay, so initially it starts. This would be, initially +6 plus 0, but when they touch one another, then the total thing is going to be +6. But this is going to be +3 and +3. Right? And so the Q total is still 3 plus 3 is 6. But Q of the silver is now going to be 3 coulombs. Then the charge of the brass is going to be 3 coulombs, both of them positive. Okay, how much charge was transferred? Well, it was at 0, now it's at 3, so the charge is +3 coulombs were transferred. And if we wanted to, we could figure out how many electrons that was, just like we did up here. All right, so again, you just look at it and look at the total number of charges anytime. So let's look at another example. Okay, so a silver sphere is -5, and the bronze sphere is -1. Okay, so the total charge, Q total, is going to be -5 plus -1, which is -6 coulombs. All right, so when they touch, they're going to share all -6. Right, so both of them together is going to be -6. So since they're the same size, and we're only going to be dealing with it when they're the same size, one's going to be -3, the other one's going to be -3. And then when you pull them apart, they'll each have a -3. And so how much charge was transferred? So I guess we can write it here. Right, well, the final charge of each sphere is -3 coulombs. And how much charge is transferred? Well, we went from -1 to -3, so that would be -2 coulombs of charge, or -5 to -3, which would be +2. So we would just say there's -2 coulombs of charge, or 2 coulombs would be okay as well. +2, because it depends on which one. So that would be 2 bronze, 2 the silver. Okay, and then last question, how many electrons were transferred? Well, we know, again, Q total is number of electrons times here. It's not really here, it's not Q total, it's Q transferred. Right? We know that's -2 or 2. It's either one's fine. Number of electrons times the charge of an electron. We just multiply that out. So we see that the charge is transferred to be 1.25 times 10 to the 19th electrons. Right, we just do 2 divided by -1.6 to the 19th. We get that big number. Lots of electrons being transferred. All right. So let's talk about the 3 different ways we can conduct or charge an object. Right. So the first one is charging what's known as by conduction. Okay. So basically, you take something that's charged and then something that has a different charge, or maybe no charge at all. And if you touch them together, electrons are going to conduct from one to the other. And that's what charging by conduction is. Basically, conduction is the charging of an object with direct contact. They touch one another. If a negative object touches a neutral, the electrons will spread over the both, making them both negative. If a positive object touches a neutral body, then the electrons on the neutral will spread out and make both of them positive, because they both will be lacking electrons. A way that you can tell if something is charged or not is to use a device known as an electroscope, and we'll get to that in just a little bit. Right? But this is a picture of what an electroscope would look like. These leaves down here, if there is a charge, they will separate. And we'll talk about how that works in just a few minutes. All right, so the first way to conduct something is charging by conduction. All right, you can take a balloon like this, right? And if that balloon is charged, and I bring it and I touch it to an object, then we're going to see that it is actually charged. So I'm going to charge that up. This is an electroscope, and if you notice that when I touch it, I don't know if you can see the thing spreading out, but the little foil thing spread out to indicate that there's a charge. And by touching it, we transferred the electrons directly by actually touching it. That scope would be said to be charged by conduction. Right. The next one is charging by induction. Right? You're essentially inducing a charge. Okay, you're charging an object without contact. Okay, this is not permanent. It doesn't stay. Things do not stay charged after that. Not permanent. All right. So, for instance, this is a good example. Right. If I have a neutral metal sphere, it's a little metal ball hanging from a string, and I bring a plastic rod, plastic comb, something that's been negatively charged. If I bring it near it, but notice it's not touching, right? Not touching. Right? The electrons in the rod and the electrons in the sphere are going to repel one another. Well, the plastic rod is an insulator, so they can't move. The electrons can't move. But in the metal sphere, the electrons will move as far away as possible, so they're going to move to the opposite side of the sphere, leaving the other side positively charged. Now remember, the protons don't move, it's just that now the electrons have moved to the other side, so this side is positive. Well, the positive side is closer, and so it's actually attracted to it. So you see that the ball is actually being pulled towards the rod, and that ball is charged. It's what we call polarized, all right? Meaning that one side of the ball is positively charged and the other one is negatively charged. But as soon as you move this rod away, right, since no electrons actually transfer, as soon as that rod moves away, these electrons just kind of move back and spread out again, and it becomes neutral again. So it doesn't stay permanent. You just bring it close, it moves, and then it comes back. Okay, and the last type is charging by friction. Right? And you saw me do this once already. If I take a balloon or just really anything and you just rub it up against your hair or rub it up against your shirt, right, you are literally transferring electrons from your hair or your shirt onto the balloon. Okay? And it's done through friction. That's why it's called charging by friction. So it's rubbing two objects together, allowing the electrons to move from one object to another. Okay, everybody's slid their feet across the carpet and then touched something metal and gotten shocked. That's right, and you got shocked because you were charging yourself by friction by sliding across the rug and transferring those electrons to you. Right, same thing happens in a dryer. Right, the sweaters rub up against one another, they transfer charge, and they become charged, and they stick together or they shock you. And then a final type of thing we want to talk about is grounding. Right. Grounding, you ground something to give an alternative path for the electrons, so the electrons don't build up. Right, it keeps the charges from building up too high and shocking you. Okay, lightning rods are a great example of grounds. Okay, the third prong on the outlet, like one, you're again going back to your dryer. Your dryer has a motor and it's spinning things. Right, that dryer, the motor that you plug in, is grounded. Because if it wasn't grounded, all the electrons that get separated when the clothes are bouncing off one another, when the motor's going on, if it wasn't grounded, that would all build up on the outside of that dryer. And if you went and touched it, you'd get shocked. Right? Still sometimes get shocked when you do that. But by grounding it, it gives the path, all the electrons that would start to build up there move away. So basically, you're giving a path for the electrons to go from some object to the ground, right? Because the ground is the Earth, right? And the Earth is so big, it can take as many electrons as it wants without really changing what its charge is, right? So grounding is just giving the electrons that might build up on something a way to go, right? If you shuffle your feet against across the carpet, if you want to ground yourself, you just touch the wall. Even though the wall's not really a conductor, the wall will take enough of your electrons, pull it away from you slowly, so you won't get shocked if you get touched. Right? But if you touch something metal, it's going to shock you because it's going to pull all those electrons out really, really fast, and you're going to get that. And it's also, but that is still